You know, have you ever tried to build a web app that's supposed to work flawlessly offline? And it does, right up until a user tries to save something. Then, bam, you hit a wall. Well, in this explainer, we're going to dive into that exact problem, one of the most frustrating things in web dev, really, and we're going to solve it for good. We're talking about making sure user data is never lost, even when the network completely vanishes.
Oh, we've all been there, right? Either as a user or maybe even worse, as the developer who gets the angry bug report. You know the drill. You pour your heart into writing this long form, a detailed comment, a thoughtful message. You hit save and poof, it's just gone. It evaporates into thin air. And that single moment, it can absolutely destroy user trust. It makes an app that could be brilliant feel completely broken. And here's our culprit, that angry red text in the console that just makes your heart sink. Every developer dreads seeing this. Failed to fetch. You know, this is so much more than just an error message. It's basically the digital tombstone for all your users' hard work. It's a sign of a massive failure in the offline experience. So let's really picture this scenario. Imagine your user is on the subway, right? The connection is kind of spotty, they're updating their profile, typing out this awesome, detailed bio, they hit save, and just as they do, the train goes into a tunnel. The network drops, and that's it. All that work is instantly destroyed. So the big question is, how do we stop this from happening? How do we prevent this digital evaporation? And, you know, this highlights a really common trap we fall into. An app can feel totally offline ready. I mean, users can read articles, they can see their dashboard, browse profiles. All the stuff that uses GET requests works perfectly because it's cached. But the second they try to write data to make a POST request, the whole illusion of being offline capable just completely shatters. Okay, so why does this even happen? I mean, it seems logical, right? If we can cache all the incoming data, why can't we just do the same for the outgoing stuff and just, send it later? Well, the answer comes down to a really fundamental limit of the main tool we all reach for when we think about offline. And this is really the moment of truth. If you've ever seen that failed to fetch error when trying to save offline, you have run headfirst into the hard limit of the Cache API. Don't get me wrong, it's an incredibly powerful tool, but it just was not built to solve this specific kind of problem. Yeah, a good way to think about the Cache API is like a one-way street. It is absolutely brilliant for GET requests, perfect for caching your app shell, articles, images, all the stuff that makes the reading experience super fast and reliable. But, and this is the big but, you just can't cache a POST request. You can't cache any kind of data mutation, and that, right there, is the absolute core of our problem. So that brings us to the million-dollar question, doesn't it? If our standard tool, the Cache API, fails us when it comes to writing data, what's the alternative? What do we do? How do we actually build an app that can confidently save a user's work no matter what the network is doing? Well, the solution is to actually change our whole approach. We have to stop trying to send data directly to the network the moment the user hits save. Instead, we need to build what's called an offline queue. This move effectively decouples the user interface from the network itself. They become two separate things. And the foundation for this whole new architecture is something called IndexedDB. Now, this is not just another simple cache. It's a real, honest-to-goodness, transactional database that's built right into the browser. So by saving our outgoing data here first, we create this super secure, persistent offline queue. The data's now totally safe, right there on the user's device. It doesn't matter what happens to the network anymore. Okay, so here's what the new workflow looks like. It's 3 steps. First, when the user clicks save, we grab that event and we do not try to send a network request. Nope. Second, we take that form data and we save it directly into our IndexedDB queue. It's now secure. And third, and this part is absolutely key, we register something called a sync event. We're basically telling the service worker, hey, there's work to be done later. But how does the service worker know when later is? How does it know when to actually send the data? This is where our real secret weapon comes into play. The background sync API. And you gotta understand, the background sync API is not just some simple timer. Think of it more like an intelligent, patient event listener. It's a service that lives at the browser level, and it was designed for this exact scenario. It just waits patiently for the perfect moment to act. So how does this magic work? Well, when you're offline, it just queues up that sync event you registered. The second a stable connection is found, boom, it fires that event.
But here's the really incredible part. This works even if the user has navigated away or completely closed the tab. The browser itself manages the whole process. And what if the sync fails for some reason? It automatically retries, using an exponential back-off strategy. It's so reliable and powerful, which is exactly why it requires a secure HTTPS connection to even use it. So when we combine our indexed DB queue with this super patient background sync worker, we get something amazing: guaranteed delivery. Let's walk through what the new user experience actually looks like now.
Okay, check out this new super resilient journey. Our user hits save while they're offline. And what do they see? An instant success message. No scary red errors, no endless spinning loaders. The UI feels incredibly fast because from its perspective, the work is done. The user can literally close the tab and forget about it. Then, later on, whenever they get back online, background sync wakes up the service worker, pulls the data from our queue, and sends it off to the server. The user never, ever has to think about it again.
And that is the transformation. By completely decoupling the UI from the network, your application goes way beyond being just a fancy offline reader. What you've built now is a truly robust, completely offline writable platform. It's an app that respects the user's effort and guarantees that their work will never, ever be lost again. So, the next time you're building an app with offline features, I want you to ask yourself this. Yeah, your app is offline readable. That's great. But is it completely offline writable? It's one thing to let users browse content when the network is gone, but have you truly protected them from that horrible evaporating form? Have you made your app a place where their work is always safe?